Welcome to Energy Law with Energy Law Prof. One of the things that I like to cover pretty early in the class is just a brief introduction to some of the principal electricity sources that we use, especially here in the United States. So we've talked a little bit about this diagram, which can be really helpful if you want to understand energy use and the different energy sources that you use in the United States. And so remember, this is called the Sankey diagram. It's from the Lawrence Livermore National Laboratories, and it's showing all the different sources of energy that we use in the United States. And so you can see that on the left, it's kind of a flow diagram. These Sankey diagrams are a flow diagram. It's showing you on the left the sources of energy, and you can see that the two biggest sources of energy are petroleum, i.e. oil, and you can see what it's mostly used for on the right. So you can see that petroleum mostly being used for transportation, for all those cars and trucks that we use to transport ourselves and our goods across the United States. And then you see the second biggest source of energy is natural gas, and that is used for a lot of different purposes. A lot of it goes into electricity generation, some of it goes for industrial use and otherwise. And so it's important to remember when we're looking at the energy system that it really has kind of these two sides. One is all these fuels that, like petroleum, mostly get burned directly for energy. That's energy used for transport or industry, and some like natural gas that go directly to people's houses and it's burned for heat there, or industry and used in different industrial processes, including for heat. And then there's a lot of another side of the energy system. You can think of it as kind of like another half of the energy system that basically goes through electricity. So that electricity here in orange at the top of the chart is showing that intermediate stage where other sources of energy, whether it be coal or natural gas, wind power or solar power, is used to produce electricity, and then that electricity in turn is used for a lot of other purposes, for driving all of our electrical appliances, for heating our houses, etc. And so you can see that electricity going across the economy, being used in residences, in commercial spaces, and industrial spaces, and a tiny bit of that going to transportation. We'll look more at the Sankey diagram in the course. One thing that's helpful is note the units that it's in. It's in quadrillion BTU, i.e. quads. We call them quads, quadrillion British thermal units. And it's helpful because in the United States we use about 100 quads of energy a year. And so that can give us kind of rough ideas of what the proportion of some of these different energy sources are. So if you see that petroleum is 35.8 quads, that means it's about 36% of U.S. energy comes from petroleum, comes from oil. About 33% comes from natural gas. Now, because today we're going to be talking about some of these different sources of electricity, we're going to zoom in on kind of the top of this chart. Note that that kind of means we'll be leaving to a side, for the most part, petroleum, because most petroleum gets used, as we can see, for industrial or transport purposes. Here on the right, very little of it goes into electricity generation. As we'll talk about later in the course, there's still some circumstances where we burn oil for electricity, but that's usually not done here in the United States, in part because it's dirtier, in part because it can often be more expensive. So let's zoom in a little bit on electricity generation and just talk about everything but kind of transport, all those other sources of energy that first go through electricity generation before we use the electricity from them. And you can see some of these very important sources: solar, nuclear, hydro, wind. We see that the biggest source is natural gas, and we'll kind of zoom in on that. And we see that coal is a big source of electricity generation as well. And so we're following this from the left, the sources, through electricity generation, and then the things that electricity is used for. And so we're going to take a moment now to just talk about what are the different sources of electricity used in the United States, what are some of the sort of benefits and drawbacks of relying on those sources as a source of electricity. So first, let's look at the US as a whole and say, how much power do we get from each source? And what we'll see is that it's relatively convenient because basically you can divide US electricity sources into fifths. And 2/5 come from our biggest source of power, which is natural gas. So in light blue on this chart, you see that natural gas now provides about 40% of US power. Same thing would be true in Texas, by the way. It's a little bit more than 40%. And then you see that the other 3/5 come from 1/5 each renewables, which includes hydro, solar, and wind, and we'll talk about all of those sources, from nuclear, and then from coal. I also want you to see from this chart that there are two sources that are on the rise. Natural gas is on the rise, and renewables are on the rise. And so you can see both of those moving up, the light blue and the green, as we reach the end of the chart. And you can see that another source, coal, is definitely falling off. So in that kind of ugly yellowish brown color, that mustard color, you see coal power falling off. Now, this is another chart that shows you what power plants were built and what were retired over the previous years, and what kind of power plants are projected to be built in the future and what are projected to be retired. So above the line, it's showing you what kind of power plants were built up to 2021, and then in the future, what kind we believe will be built in the future. And what you can see here is that we're expecting more of this trend toward more reliance on natural gas and renewables. So if you go up to 2021 and you look at what kind of power sources here above the line were built, you're seeing mostly light blue natural gas power plants, and in green, wind power plants, and especially recently in yellow, solar power plants. If you look at what's projected to be built in the future, again, light blue, natural gas power plants, in yellow, a lot of solar coming on the grid right now, and then in green, more wind power plants. Now let's look at below the line. What kind of power plants have been shut down recently? And remember, we always want to look at these charts and think about which parts of this are a measurement from the past and which parts are projections for the future. Because obviously we have a lot better idea of what's happened in the past than what will happen in the future. But these are the projections that we have currently. So you can see that in light gray, there's been a lot of coal shut down in recent years, and that there's projection for more coal to be shut down in the coming years. You can also see some nuclear in red shut down, and a lot more nuclear in red projected to be shut down in the future. And so mostly this is telling you that what we expect is an increased reliance on renewable sources like solar and wind, and natural gas in the future. So those projections, so those trends that we've seen toward more dependence on gas and solar and wind will continue. All right, now let's talk about why are some of the reasons that you might choose to rely on one source of electricity versus another. So remember, this whole part, we're not really talking about direct use of fuels. We're talking about the use of fuels for electricity generation. If you were thinking about how to build an electricity grid, what sources would you use? In the United States, until relatively recently, you saw in that chart, coal was the biggest source of power. Now, what are the benefits of coal? Well, it can be pretty cheap, especially if you don't control a lot of its air emissions. As we'll see, it can get more expensive once we impose controls on it to reduce its pollution, which we'll see is one of the big problems from coal. One of the huge reasons that coal led to the modern world, that it drove the Industrial Revolution, is that it's easy to transport and store. So coal power, when it really became dominant in the 19th century, wasn't necessarily cheaper than wind power or water power. It was just that you could gather that coal into cities and put a whole bunch of industry next to each other because of its ability to gather. And it enabled the rise of the modern city as well, because you could gather enough coal to drive a modern city instead of having to go to the countryside looking for wood to heat your city. So it's easy to transport and store. We'll also see that makes it more easy to ensure that you always have the supplies you need, because you can store it up against future shortages, and if there's some place where there's a shortage, you can transport it to where it's needed. So that can make it more reliable. It's huge reserves of coal. Most people don't expect that we'll ever burn all the coal that we know is out there already. Those are a lot of sources of it across the world, and obviously it's an existing technology that we know how to harness for energy. Now, for all those huge benefits, and we've talked about somewhat about how they're crucial to our civilization, building our modern world, it has huge drawbacks as well. Principally, the single biggest in terms of cost-benefit terms is its high air emissions. It just leads to very bad air pollution that has a huge number of negative health impacts, and show you some visualization of that. It also has high carbon emissions. So as we'll see with any of these fossil fuels, the way that you get energy from them is by releasing carbon dioxide and energy. And those carbon dioxide emissions are what cause global warming. And coal, because it doesn't burn as efficiently as some of those other fossil fuels like natural gas or even oil, has actually more carbon emissions for the amount of energy that you get out of it. So it tends to have very high carbon dioxide emissions. And so for global warming, coal is often considered the worst source for those purposes. Now, coal can also be more expensive than natural gas power in places like the United States, where we have a lot of reserves of natural gas and we have a lot of environmental controls on emission from coal. So coal is still the cheapest source in big parts of the world where they don't have as much natural gas or they don't have as many environmental controls. But often in the United States, natural gas can be cheaper given how big our natural gas supplies are. Another downside of coal, and we'll see how crucial this is to the electricity system, is that it's a little bit hard to just get more or less power from your coal power plant. It's much easier to do that with a natural gas power plant. And what we'll see is that we need some power plants that can vary their delivery of electricity to the grid, and coal has a hard time doing that. It's not like the accelerator in your car where you can just get as much or as little power as you want. Often you kind of just want to run the coal plant full out or not at all. Another challenge with coal is that there has obviously been increasing pressure to abandon coal as a source of power, increasing international pressure because of concern about climate change. And so there are a number of international organizations that are looking to reduce or eliminate coal power plants around the world because of their impact on climate change. Now, it is important to emphasize coal was absolutely crucial to the development of our modern civilization. And so if you look at urban growth in Europe, there's some projections that 60% of urban growth during that Industrial Revolution were due to coal. And so we've talked about this before, but basically if you're in Europe, often if you're in a city, it's often a city that grew up around a coal field. And even if you're in a city that is a historical city that existed long before coal was harnessed on a wide scale, a lot of times there'll be a core of that city that existed before coal power, and then it expanded massively after that. So you'll often see kind of like a medieval core and a much bigger modern city enabled by the industrialization driven by coal and the ability to bring coal into those cities. Certainly when you look across England, and here on the left you're looking at picture of population density, you can see how where people live, at least in the Midlands and North, often corresponds very closely with where there are coal fields. And you'd see that in Germany and other places across Europe as well. Now, the big downside of coal power, and this became very important in the 20th century, was that it just causes terrible air pollution. So if you've heard of London fog, historically that mostly referred to the air pollution caused by coal power. And this was a huge problem in the United States in the post-war years as well. We had fast economic growth, as usual, that goes along and is driven by a rapidly increasing power use. But when most of your power comes from coal, that can cause terrible air pollution. And you can see an example of that on the right in China, where that's Shanghai on 3 different days, and you can see how from the best day there's still a lot of pollution in the air, whereas on the worst day you can barely see anything. And that is the reality in places that are extremely dependent on coal power. So that was from 2013. Since then, China has done a lot to clean up their air quality, but there are other parts of the world where they are focused on economic growth and still increasing coal use significantly, and China as well is another one of those, although it has tried to drive some of that coal power use out of its cities where it has the most human impact. Okay, so Natural gas. Now we saw that's the biggest single source of power in the United States, responsible for 2/5 of our power, and we can see it has big benefits. So one is if you have big reserves of natural gas, if you're producing a lot, and the U.S. is the world's #1 producer, it can be very cheap. It can be a very cheap source of power. It has lower greenhouse gas emissions than coal. So it has 50 to 60% of the emissions of coal. So it helps, and that the increased use of natural gas driving coal out of the power mix is one of the big reasons that the United States in recent years has been able to cut its greenhouse gas emissions so much. It also has much, much lower air emissions. So all that pollution, remember those greenhouse gases, carbon dioxides, generally, part of the air we breathe, not a problem. The air emissions that cause that haze that you can't see through, those are the ones that have really immediate health impacts on anybody breathing that, particularly vulnerable populations in bad health or people with asthma, etc. Those can cause hundreds of deaths if you have if you had a bad situation with high air pollution. And natural gas, as we see, has much lower air emissions. I mean, that's why you don't burn coal in your house. You would never do that, but of course many of us burn natural gas in our house because it's smokeless. It doesn't have those air emissions, and we'll look at an attempt to quantify that. It is also reliable, and as we'll see, this is particularly important. And reliability, all sources can have different reliability challenges. We'll talk about some that can impact natural gas over the course of our semester. But the one key thing here is that it can vary. So like that accelerator on your car that can provide just a little power or a lot of power, natural gas power plants can do that. And as we'll see, that makes them play a crucial role within the power grid system. Possibly large reserves of natural gas. We're constantly finding new natural gas reserves, and we've been able to unlock huge reserves through the use of fracking, which we'll discuss later in the course. And also, this is a technology that is both existing, but we're constantly improving and learning how to make it better. Now, so what are some of the drawbacks? Well, one of the first big drawbacks is that natural gas is expensive to transport and store. So, unfortunately, when we think about our energy sources, if you take it from the dirtiest coal to the cleanest electricity, you can say, well, coal is the dirtiest, and then we have oil that's a little bit cleaner, and then natural gas is much cleaner than that, and then the cleanest would be just solar, wind, nuclear power, sending something like that to the grid. Unfortunately, that spectrum is the same spectrum from easy to transport and store, like coal, to difficult to transport and store, like electricity and like natural gas. So, with coal, you can send it by ship, by rail, by truck. You have, lots of ways to send it, and you can just pile it up for when you need it. With oil, you can also send it, again, by ship, by rail, by truck, also by pipeline, and you can store it, as a liquid. Now, by contrast, natural gas is so voluminous and so big, very difficult to store. You have to find an underground reservoir that can hold a huge amount of natural gas if you want to store it. And it's also very hard to transport. You have to build an airtight steel pipeline to take it from where it's produced to where it is needed. And that's a very expensive and, as we'll see, legally difficult process. And so there's no quick way to transport natural gas to some new destination that needs it. It doesn't already have the infrastructure built out, and the infrastructure itself to build is very expensive. Okay, what are some other drawbacks? Well, it still does emit greenhouse gases. It is a fossil fuel. So as I said, every time you're burning a fossil fuel, that's to release carbon dioxide and energy. The energy is great, you can use it. The carbon dioxide causes global warming. Okay, methane leakage. Now this is an added difficulty with natural gas, which is that natural gas mostly, as we'll discuss later in the class, is methane. And methane, if you don't burn it and just release it to the atmosphere directly, it's actually worse for global warming. It can be substantially worse, more than 20 times worse for global warming than just burning that methane and just releasing the carbon dioxide. Now, that's not a problem if you do what you want to do with the natural gas and get it all to the market where it needs to be used and burned for energy. but often natural gas escapes through the extraction and transport process, and the more it does so, the worse natural gas gets in terms of its impact on global warming. Okay, other challenges with natural gas. Well, there's uncertain reserves, and that means that there's uncertain prices. And so we don't, it's not like coal where we just have so much that we're thinking, oh, it'll always be relatively affordable. The reserves can change over time. Yes, we're constantly finding more, but sometimes there are big changes in natural gas prices. So the U.S. for a while, when it fell back in its natural gas production, was experiencing higher natural gas prices. Now, we're by far the world #1 natural gas producer, and we have lower prices. Also, natural gas, although it has less impact on the climate than coal, there's still a concern that there may be international pressure to abandon natural gas because it does emit carbon dioxide, which can cause global warming. Okay. Now, this is sort of uncontrolled burning of coal, oil, and natural gas. But what I want you to see here is, on the left, in terms of the carbon dioxide emitted for a certain amount of energy, you see that natural gas is again about 60% of the emissions of coal. So substantially lower carbon dioxide emissions. That's why it's substantially better for climate change. But you can see it's not a full solution. Nuclear would be 0, right? Or solar would be 0. Now, by contrast, if you look at emissions of things like sulfur dioxide or particulate matter, you see that natural gas emissions really are quite close to 0, and that's why people burn in your house. Of course, like when you're burning anything, you want to have safe ventilation, but it is that is why natural gas, we say it is smokeless. It's why it is such a huge benefit to have natural gas instead of these other fossil fuels burning if you're around people. So a lot of cities have moved to compressed natural gas to drive their buses because instead of burning diesel, they want them burning natural gas because natural gas emissions are so much lower and have such a huge beneficial impact on cleaning up the air, particularly in urban areas where you have a lot of energy use. All right, here's the other crucial thing about natural gas. Its crucial benefit is that ability to vary. And to understand that, and we're going to talk about this in the context of wind and solar as well, you need to understand something crucial about the electricity system. That may be the thing that's sometimes hard to understand or might be counterintuitive, but is most important to understanding electricity policy. And that is that the power grid has to exactly balance how much power is demanded by millions of consumers every time they flip on a light switch or turn up their electric heat or plug in their electric vehicle or plug in their laptop. The electric grid has to balance that with how much power is being produced by hundreds of different power plants. And that is a huge challenge because if those things ever fall out of balance, you can have a catastrophic chain reaction that takes down the whole grid and costs hundreds of human lives, billions or trillions of dollars. It is a huge, huge potential problem. So how do we manage this? Well, a lot of our power sources are, like we said, with coal or nuclear. In this chart, you can see the coal and nuclear in dark gray and light gray, and they basically just run all the time, flat out. And that's great because we use some minimum amount of power all during the day. But what this chart is, the overall level of this chart is showing you is the amount of power used over a course of a day from midnight to midnight. And you can see that, as you might imagine, that varies, right? People wake up, they turn on the lights, maybe they turn up the air conditioner, they change their electricity use in millions and millions of ways. And the power grid has to exactly balance that. Well, how does it balance that given that power sources like coal and nuclear just run flat out? The way it does is with natural gas, which you see in that light tan color here, going up and down, ramping up and down to match that demand with supply, minute by minute. So ramping resources play a crucial role in ensuring that the power grid stays up, that we don't have a chain reaction that takes it down, causing true economic and human catastrophe. Natural gas ability to ramp up and down makes a huge difference in ensuring that that grid stays up. And we'll talk more about that. Okay, Another important power source, again, about a fifth of US power comes from nuclear. What's the benefit of nuclear? Well, the biggest benefit, no greenhouse gases or air pollution from the power plant. Sometimes people will say, well, it's really more complicated because the power plant took a bunch of concrete and steel, you had to mine for uranium, and all of those things emit carbon. The point here is when we say there's no greenhouse gas or air pollution, we mean that the plant itself doesn't emit any greenhouse gases or air pollution. Of course, the things that went into the plant, that's called a life cycle analysis. Yes, of course, you likely emitted carbon for those parts of the plant. That would be true of any industrial project, right? So we're not talking about a life cycle analysis where we think about everything that went into it. We're just talking about the plant itself. The plant itself does not emit greenhouse gases or air pollution, unlike a coal power plant or unlike a natural gas power plant. Okay, another benefit, it's reliable baseload. Now baseload means, it's just kind of straight on, and so it doesn't tend to ramp, so that makes it kind of more like a coal plant, but it does provide that kind of baseload power during the day. What are the drawbacks? Well, probably the biggest drawback is that there's often a lot of public opposition to nuclear power plants, and that actually can cause a number of compounding problems. There also can be some security risk. I mean, ultimately, a nuclear power plant is not going to cause a nuclear weapon. It's completely, the level of refining isn't comparable. But there is you obviously have to safeguard radioactive materials because those radioactive materials themselves would be dangerous if they were, if they fell into the wrong hands, because radiation is a risk that you don't want spread in various ways. All right. What are the other drawbacks? Well, it's a massive upfront investment. These tend to be, $10 billion projects easily, and often that means that they cost more than an equivalent natural gas power plant would be, and they don't have that ability that natural gas has to ramp up and down. So we'll talk more during this course about some of the challenges with building nuclear power plants, but it's enough to say that some of the recent efforts to build nuclear power plants have kind of been spectacular failures where they've gone way over budget and then ultimately were canceled. Now recently they've been able to actually finally open some nuclear power plant in Georgia. It's very exciting, but even that's very over budget. There were examples like South Carolina where basically they went massively over budget and ultimately weren't able to build anything at all. So if you can imagine trying to explain why you spent $90 billion and got nothing for it, that's a huge challenge, and in part, as we'll see, that's tied to all the difficulties of building a project that often receives a lot of public opposition. Okay, other sources of power. Okay, wind power. One of the areas we've seen the most construction in recent years, and the biggest sort of boom in terms of increasing electricity generation for wind power. Again, like nuclear, the wind turbine itself does not emit greenhouse gases or air pollution. Now, of course, again, you could do a life cycle analysis and say, well, it took some steel, it took concrete, etc., and you emitted carbon dioxide to produce those, but the facility itself does not emit greenhouse gases or air pollution. It doesn't have fuel costs because it just is running on the wind, and its costs are falling. Often it's the cheapest source of power at the source. We'll talk about that. Okay, what are some drawbacks? Well, one, it's not dispatchable. That means you can't determine when it turns on. And so, keep in mind, that's even worse than not ramping, right? We obviously need some ramping sources, but if you have a source that you can't even determine when it goes on, that makes it very challenging to ensure that the power grid is always exactly balancing how much power is being produced with how much is being demanded. And we'll see the challenge of what dispatchability, the lack of dispatchability of wind, why that makes it so difficult to balance the grid. All right, it also requires transmission. So often wind power is located in the windy prairies, in places where not a lot of people live. Power is mostly demanded in places where people live, or at least where there's a ton of industry. And so that means that getting power from where it's generated at the wind turbine to where it's needed in cities often requires long distance transmission, which is expensive and is also complicated as a regulatory matter to get approved. So you remember how that's a little bit like the natural gas problem, where you have this source of energy that's cleaner, But because it's so difficult to transport, in the case of electricity, it can only be transported by power line. That means that you have a real challenge with building the kind of transmission needed to make this wind power have the value it should. All right. Also has a large land footprint. Now, often you can use the land under wind turbines for agriculture or other purposes, but certainly it takes up a lot of area to get energy. There's different estimates, but I've seen estimates that basically, if you take, oftentimes people say, well, instead of having these offshore oil platforms, why don't we have offshore wind turbines? And depending on how much oil that offshore oil platform is pumping, often it would take thousands of wind turbines to get the same amount of energy. So wind takes a lot of energy, a lot of space to produce the energy it produces. Wind also, of course, those wind turbines can kill birds. People will say, which is accurate, that domestic cats kill more birds than wind turbines. True, of course. Domestic cats don't take down bald eagles or golden eagles. So wind turbines obviously present a unique risk to some of those big species that often we particularly care about, or sometimes we'll see examples where they have an impact on endangered species or otherwise. So it is true that they kill fewer than domestic cats, but they kind of present different issues, and we'll see that sometimes that is a major the major issue that is addressed, that has some wind turbines have had to address. And you trip them up legally in terms of siting. Okay, so here you can see a chart of where wind is strong across the United States. What I want you to notice is that wind can be very strong, purple and red here, across those sort of prairies. If you go from North Dakota down to West Texas, it can be very strong. We'll see that Texas actually has more than three times as much wind power as any other state, in part because it has the good fortune of having strong wind in the west, but in the east, big cities. And a lot of those other places where there's wind, they're quite a ways from cities, and so that makes building that transmission a big challenge. Often they go across multiple states as well, which we'll see is a challenge. So a lot of, you can see that the U.S. Southeast, where there's a huge and growing population, doesn't have very much wind. And so one way that we could use a lot more wind power is if we could get transmission built across the United States from the windy prairies to the big urban centers in the Midwest and the Southeast that could use that power. You can see that the wind footprint also very large. This is showing it about 1,000 times greater than a nuclear power plant. Also note that the nuclear power plant would at least run all the time, even if it didn't have the ability to ramp as we needed, whereas the wind farms would run when the wind was available. Okay, solar. We'll see in some ways a similar profile to wind, but we'll see some slightly different benefits. So again, like wind, no greenhouse gases or air pollution. One big benefit, and we'll see this is very important, solar power, of course, peaks when the sun is highest. And that we'll see that that's valuable because that lines up better with when people typically use power. We can also see that it tends to use a little less land than wind. It's a little bit more efficient in terms of its land use. Like wind, its costs are falling and it doesn't have fuel costs. Drawbacks, as we said, with wind, it's not dispatchable. You can't choose when it goes on. Often requires transmission, although not always. It sometimes can be located a little bit closer to cities, and certainly we have rooftop solar as well, but it still does have a large land footprint. And I should note, unlike wind, where you often have agriculture underneath, solar farms very rarely have any agriculture underneath. In theory, it's possible. In practice, it doesn't happen hardly ever. Okay. So here's one of the big challenges about the lack of dispatchability, the fact that you can't choose when solar and wind go on, which is that neither of these sources is particularly strong when people in the United States generally have peak power consumption, which is usually the early evening, kind of like right after sundown. And so what I want you to see is here on the top left, you can see solar power shifting across the United States. Obviously, there's no solar power at night, but as you get to the middle of the day, you see a wave of solar power pass across the United States. Of course, it goes away as the sun sets. Okay, what I think maybe fewer people would know is that wind power also has a diurnal, a daily pattern. You can see in the bottom right, which is that wind power tends to be strongest about 3, 4 a.m. in the morning, and then it kind of goes away in the afternoon and early evening hours. And that's a particular challenge because, as we'll see, when power is typically most needed is in those early evening hours when often you don't have very much wind at all. And in fact, solar, some places, if they have a little bit earlier peak, there still may be some solar left. That's true in Texas. But in a lot of places in the United States, they would have a peak that would happen right after sunset. And so there's no solar available either. And so that can create a big challenge. So let's look at a power grid in the state of California. This happens to be a date in March 2017. Nothing went wrong with the grid this date, but this is just showing you how much power is demanded from midnight to midnight and where that power is coming from. So, if you start at midnight, you see people, if they're not already in bed, are starting to go to sleep, and you get a minimum of power use, kind of 3, 4 a.m., by the way, when wind typically peaks. Then you see as they wake up, you see more and more power being used. And then this is fairly typical for much of the US. You see that the peak comes in the early evening hours. Everybody gets home, they plug in their phone, they maybe plug in their Tesla. And so that's when we get peak power use. Now, where's that power coming from? Okay. So in yellow and green, this is solar power. And you can see that solar power provides a ton of power during the middle of the day. And that is great if you have other sources that can ramp down. And California, like the US, uses a lot of natural gas. And so those natural gas sources are able to ramp down during that period. And so that means that renewables and natural gas actually work quite well together. And often we think about renewables as fuel-saving sources because basically they allow those natural gas power plants to ramp down, stop burning natural gas, and save us that natural gas fuel, which saves us money and, of course, also reduces carbon emissions from those natural gas power plants. But now I want you to see what happens in the early evening and when everybody's coming home and you actually have peak demand. You'll see that when we have peak demand, there's no solar available. And so the grid basically has to have enough power sources sitting there ready to provide with zero dependence on solar during that time period. And that's why, to a first approximation, usually the solar and wind don't allow you to shut down power plants because you need to have them all there ready to provide the grid with no help from solar when the grid most needs power. Now, over time, we are in the middle of a big battery boom where we're building lots more batteries. But batteries are not the most efficient way to, what you might think of as basically you put a bunch of old car batteries or lithium batteries together. Those are not the most efficient way to store energy. And so you really, you can get a little bit of them in the grid and they can make money, but they can't just take this peak away. They can't basically store enough to meet the peak by themselves. They've started to get, on a really extreme day in Texas, you might get 1% of the power for a few minutes provided by those batteries. But really, they barely change this picture right now. Let's hope that in the future, they'll have a more transformative role on the grid, and so that'll kind of even up how much power is demanded from these ramping sources like natural gas. Because you can see that without batteries, what solar and wind are doing are basically meaning that natural gas power plants cannot run when they're available, but have to ramp way up when they are not available. All right, next source of power, hydroelectric. So we'll see in the United States and North America, hydro tends to be very cheap. In part, that's because those power plants tend to be very old. And so the power plants have long paid for themselves. Hydro also has this benefit that it can be used as storage. If you have reservoirs at 2 levels, if you have extra electricity on the grid, you can use it to pump water uphill and then store that water up there and let it run downhill when you need more electricity on the grid. You could also use it to load follow, so you could basically just let more water over the dam when you need more power and less when you need less power. As when we talk about hydro, we'll see that that's actually quite challenging. There can be a lot of local opposition to that from both a environmental and recreational perspective. But in theory, you could do that. so what are the drawbacks? Well, it has huge aquatic impacts. Obviously, once you dam a river, it is forever changed. And so that's been one of the reasons that there's been a lot of opposition. When you actually flood the reservoir, of course, you are killing a lot of vegetation, and that vegetation will rot and produce greenhouse gases. And so, although in a steady state, the dam may not produce as much greenhouse gases, there's a concern that when you're flooding it, it actually there's concern about building new hydropower given the flooded vegetation, that the greenhouse gases that you would have from that. Also, of course, it really depends on geography, whether you have steady rainfall, the ability to make this a reliable source, and of course, there's also a lot of local opposition. Anytime that you are, flooding a huge area, there's going to be huge opposition to that. And in fact, a lot of the dams that we have were built before we had the kind of legal protections for the process objections that you could make that we have now, that make it harder to build those kind of big industrial projects, especially when they have a big impact on local landowners. Okay. So you can see, there's been an effort to at least rely more on some of the hydropower plants that are already there in Quebec, and that has hit repeated snags. First trying to go through New Hampshire, then trying to go through Maine. It's something we'll talk about later in class. All right, biomass. So biomass, this is the, when you're basically, just imagine you're burning wood for electricity generation. So, as we'll see, that can cause very serious air emissions. Actually, it tends to be even less clean than coal. So what's the possible benefit? Well, the benefit is, in theory, if you have a forest where you're constantly, taking trees to burn for electricity, but at the same time, growing trees at the same rate, those growing trees take carbon dioxide out of the atmosphere. So even though your power plant, burning trees, is emitting carbon dioxide to the atmosphere, your trees are pulling carbon dioxide out of the atmosphere. And so the theory is that's carbon neutral, that you are pulling as much carbon from the atmosphere as you're emitting when you're generating electricity. And that can be a relatively cheap source of power. I mean, it's not exactly a complicated process, burning trees. But challenge is that there's a huge amount of debate about really how carbon neutral is that, because as you can imagine, you're kind of comparing with a hypothetical state of the world if you didn't have the power plant. Because what if you didn't have the power plant, and that meant that the forest would just keep growing? And so it would have been taking the carbon dioxide out of the atmosphere anyway. And so really all you're doing by burning the forest is keeping it from growing and adding carbon emissions to the atmosphere. So it's really, that would be an argument that it's not actually carbon neutral. As you can see, that's a big challenge. So those are our big sources of electricity. The one we didn't cover in this is geothermal, but we covered the main sources: coal, natural gas, our biggest source of electricity in the United States, wind, nuclear, solar, and hydro.